Hey everyone, this is Daniel for Rock the Code, and in today's episode, my guest is Venkat Subramaniam. He's an engineer, a consultant, and an instructional professor at the University of Houston. He's mentored tens of thousands of software developers in the US, Canada, Europe, and Asia, and he's regularly invited to speak at international conferences. He's the author or co-author of several software development books in multiple programming languages, including Java and Kotlin, and he's well recognized, I would say borderline on fame, in the software communities. He won many awards for his community contributions and is recognized as a Java champion since 2013. Venkat has been in the training, consulting, and mentoring business since 1996. And this is a wide-ranging conversation about good software practice, timeless skills for programmers, responsibility, new things added in the JVM ecosystem, programming language trade-offs, and Venkat has no shortage of good stories from his personal experience. I'll let you discover everything in the conversation. So please welcome Venkat Subramaniam. Venkat, I've been looking forward to this conversation for a while. Thank you so much for making the time.
Thanks, Daniel. It's a pleasure to talk to you today.
Awesome. So while doing the prep for this conversation, I was thinking of a good place to start. And what better place to start than the current zeitgeist, which is AI? And correct me if I'm wrong, you can't prove everything that you read on the internet, but is AI the most advanced vomiting engine ever created?
It can be if we let it to be. So one of the things that is absolutely fascinating for me is to see the power of this tool, which is really a double-edged sword. It can be used very effectively, but we can also use it to slash our fingers, or much worse, lose a few parts of our body, if you will. I think it is an engine that is good in doing things, but it really is. I often say the tool is as good as the person using it. I posted on social media a few weeks ago, maybe a few days ago, and one of my realizations is that with the changes that we are seeing right now, the smart is becoming smarter and the dumb is becoming dumber. And I think AI really is an amplifier in the hands of the person. If they have a great talent and an aptitude to get things done, it's a fantastic tool. If they don't, unfortunately, it becomes a weapon as well. So it can be a vomit generator, but it doesn't have to be. I don't think we need to let it do that.
How do you make the difference, and what kind of traits does an engineer need to have or need to build, cultivate, in order to use AI to its fullest potential to the degree that you've seen it so far?
One of the in one of the talks I'm giving, I mentioned this as a joke, but unfortunately, it would be funnier if this was not true. And I say that humans, I think we can agree humans have written really bad code, and AI has been trained on code written by humans, and humans complain that AI is writing bad code. That's karma, basically. So
Right.
essentially, my argument is this is my more recent realization or aha moment is that every single technical, what I want to call as a sustainable technical engineering practice that we have been really focusing on for the past few decades is all of a sudden more important now than being less important. So one of the questions we often face today is, with AI being so prevalent, do we care about what we do? Everything is different. And I would beg to differ. Everything is not different. Everything is really more amplified now. One of the key things, if you forget AI for just a moment, if you're developing software, one of the challenges we face as software developers is, how do you know the code that worked yesterday continues to work today? And software is a nonlinear system. And you make a change to one place, it can break things in so many other places. And I got introduced to automated testing in 2003. And I remember that day very clearly, a hot summer day, in June. And I was sitting there saying, I don't need this stuff, automated testing. I've been writing code for a while. At that point, if my memory serves me right, had been writing code for about 15 years or so. And I'm like, I don't need this stuff, right? I write code, I write good code, I write tests for the code I write. But I never really caught on to automated testing until that day, and that was a tipping point for me. And since then, I have relied heavily on automated testing. And when I make a change to the code, the feedback loop, the fast feedback loop is absolutely amazing. Well, with AI, the speed at which we can change the code has only become several orders of magnitude faster, which really means that the things we relied on earlier at our human speed becomes even more critical now with the speed of AI. So I think fundamentally one of the things we need to realize is that it's a very powerful tool, but it's not like we have a brand new world. It is a world that has shifted, but it has also shifted the emphasis on good practices, good engineering practices. CI/CD is still highly relevant. Automated testing is extremely relevant. Code reviews are enormously relevant. And one of the practices that I've been following for a long time now is when I sit down to review code, I don't review code to begin with. I review the test before I review the code. Well, guess what? We need to review test a lot more now than even the code. Because if the test is golden, the code can do things and code can change, implementation can change, but your behavior has to be consistent with what you're expecting. I think a lot of the things we've been practicing engineering wise, the problem in our industry is not that we don't have enough tools. What we lack, unfortunately, is a bit of a discipline. And I think this really is bringing forward the need to have more discipline in what we do. And I'm hoping, given that the tools are making things faster and less effort, maybe it'll relieve ourselves of the pain we go through and we can focus more on discipline, I would think.
How does one build discipline in this day and age? Now, given that LLMs produce code faster than we can read it, people have started to resort to solutions like they don't even review the code anymore. As PRs get thousands and thousands of lines of code even per day, they start to use AI to review the code that was generated by AI. So that's this turtle's all the way down. Now it's LLMs all the way down. Um, how does one build discipline? That's one side of the question. And the other side of the question is, how do you make the case for discipline as a discipline, if that makes sense, for discipline as a way of life, and
Yep.
to internalize the value of it?
The key, really, one of the things I think more of us need to ask and think about is what's the cost of failure? If the cost of failure is very small, it doesn't matter what we do. If I'm creating maybe a little game and this is for a group of people to play with, maybe the game doesn't work properly, it's broken, it doesn't function properly. Who cares? Maybe you're going to have a few grumpy people complain about it,
Right.
but it doesn't really bother anybody a whole lot. But if I'm creating an application which is involving the money of people, and imagine I mess up, it takes money away from somebody's account. They cannot pay their mortgage this month because the money was taken out, in an unpredictable way. There's got consequences to it. So to me, I think for myself, I can speak, and I'm sure it's probably true for everybody else, is I build discipline based on the consequences. I build discipline based on a concern of reputation, a concern of responsibility. And to a certain extent, our industry has kind of had a free ride for a while where they can do things and get away by not having too many consequences. But in my own experience over the past few decades, I have worked with a few companies which have been in serious legal trouble because of the poor quality of software they have created. And when attorneys get involved, when court of law gets involved, things are very different. So I think discipline is going to be a bit of a forced into what we do, depending on the consequences of what we do as well. And as more and more software is beginning to have deeper impact in society, I think it's inevitable we get to that point. Discipline probably comes from our personal desires, right? Oh, I care about my name. I care about what I produce. I care about my reputation. And I, in this case, could be an individual. It could be an organization, could be a company. But at some point, that's true. But at some point, it also could be a legal requirements. I built a semi-custom house a few years ago, and one of the things that I mean, the person who built was amazing. I have the deepest respect for this person. I have to say, I learned a lot of stuff from the way he has been running his business. But nevertheless, I live in a county where you can have a good visibility into building of a house, not from the point of view of what the builder tells you, but from a public website which the county maintains. So we could go into the website, clearly look at the day when they're coming for an inspection. We can look at what the inspector is writing as a report, what they are saying about things that are good and things that need to be improved, when they will come back for re-inspection if it's necessary, and all that accountability is in place. So I cannot just walk up to somebody and say, I'll build a house for you, hire me. Well, there are requirements I have to fulfill in order to build a house, and there are inspections along the way. And that is accountability, right? And the reason is the cost of failure is high in a building. If a construction were to fail, the people in a house could be injured or much worse. And I think that's kind of where we need to really look up to is software is beginning to have impact, and more it's going to really have bigger impact as time goes on, and either we raise up to the occasion, or I think we are going to be forced to raise up to the occasion. So the discipline is really forced in if we're not willing to take that up, as we go along.
This is a very interesting take because this basically advocates the Nassim Taleb's concept of skin in the game. So basically, you're becoming responsible by putting your own something of value that's baked into your work, and if it fails, it directly impacts you, the creator or the owner or the driver of the said thing. But in a place where so in software, as you said, we've kind of gotten away with very few consequences. I would also say it's because a lot of software doesn't have that many consequences besides annoyance, like I don't know, a restaurant failing to make a proper reservation, or a picture app that not working or displaying some broken things and stuff like that. Do you think there's a way to add that skin in the game and that engineering practice that other disciplines have, like civil construction or medical staff or similar domains, and to bring that into software engineering as a domain where we've written a lot of software for nice to have things? How do you think about that?
I think the key here is it's not often that what we desire to have. In the industries we talked about in medicine and civil construction, these are baked in by the law. These are
Mhm.
requirements that's been forced into the field. And the reason for that is because we clearly know the medical consequences. But in all fairness, if you go back in history and look at it, only about 150 years ago, doctors literally would wipe their hands on their shirts after performing a surgery because we didn't know better. We didn't know about germ theory. We did not know that we were causing the infections. But once we came to that realization, the medical industry went through a huge transformation. So it's not like these industries were born disciplined. The discipline had to be brought into those fields as well when we learned about those consequences. So I would say the skin in the game comes from the consequences more than anything else for a lot of people. And sure, you're totally right. We've gotten away with this for a while. But the question to really ask is, what if the picture you're looking at is going to lead you to make a bad decision, which then has a consequence that is much worse? Maybe a child needs an attention and you couldn't provide the attention the child needs because maybe a picture was misguiding you to a wrong direction or providing you misinformation. So I think the key here is that eventually, when software gets used, we are still a very nascent field, relatively speaking, which is kind of surprising, right? Only about 40 years ago, we were talking about compilers being this newfangled thing. And so compared to a lot of other industries, we are still relatively new. And but the days of no consequence, I think, is over because personally, I'm aware of banks that have made millions of wrong transactions or millions of dollars worth of wrong transactions, and when they have to. I was recently talking to a bank, developers within a bank, and I won't reveal the name here, obviously, but I was asking them, my goodness, what did you guys do when you found this problem that messed up literally, hundreds of thousands of customers? And there was silence in the room, and one person said, well, we quietly paid them off because there's nothing else we could do. And you can imagine the cost of that failure for the bank. And that was not a trivial, let's pay them $10 and we are done with it, right? So I think that's where the learning begins to happen. And I was involved with a company where their CEO was giving a talk at a conference when somebody from the Department of Defense walked up and served a notice to them because of the software that had messed them up. So there are quite a few evidences of this beginning to happen already. And yes, a number of software, I agree, wouldn't have that many repercussions, but that doesn't mean all of them are. Imagine a software that is maintained by the university for a student to graduate, and the student cannot graduate because it messed up the grading system, and the student now cannot get a job. Uh, this goes on and on and on. I can give you a more recent example where more closer to me, a background check ended up failing. And imagine you are seeking a new employment, and your background check fails, and you get the report. And you are just laughing because the other option is to cry because the reason the check failed was because the software could not match a string properly. And this is costing money, this is costing time, this is costing frustration. And so I think we are already at that point. We can be negligent, but I don't think that's going to outlast for too long. I think eventually we'll have to get our act together.
How should managers and higher ups think about this new wave? Because the reason I'm asking this is because it's not necessarily always the developers pushing AI or LLM generated code into their code base because they love LLM generated code. It's often because the higher ups, the CEOs, the CTOs, and then trickled down to their level, get pushed this decision that now you have LLMs, you need to produce 10 times as much code. Go ahead and do it. The clock's ticking. Other people are waiting at the door. There's massive layoffs and so on and so forth. And so there's a lot of pressure on software engineers to deliver a lot of code and push a lot of features and use LLMs to the greatest extent imaginable. How does that reconcile the disciplined and the I could dare extend this concept, the moral concept of software engineering, to literally own your consequences. How how do you imagine managers should think correctly about the new wave of LLMs getting infused into the code in the way that I've just described?
The one of the things that blows my mind is the insane desire for a reckless speed without really asking the question, right? Is this a speed in the right direction? Are we getting the results out of it? Uh, I was in a meeting with a group of programmers and a senior member of the team. And I'm so glad, I was happy to hear this because such wisdom I appreciate when it comes from the right place. So the programmers were asking and saying, you don't understand. If we were to do these things, it's going to take time. That was the programmer saying, right? And the person in the senior position immediately intervened and said, hang on a second, you're looking at it wrong. Yes, it is taking you time, but if you zoom out the timeline, this time is negligible because you are preventing so many other issues from happening when you move forward. I think this really comes back to maturity more than anything else. So if you have a senior in your organization, whether it's a team lead or a manager or a director or a VP or CTO in any level, if that person has a good maturity in terms of how they measure progress, how they measure time. So to me, time and money is this is a lesson we learned a long time ago from Toyota. They were manufacturing cars, but they would come back with defects for fixing. And so they took a while to figure this out. And they said, wait, if we increase the rigor in manufacturing, it actually is increasing the manufacturing cost, but it is reducing the maintenance cost by a greater number. So what I often ask people to do is to think about what I like to think about as a local optimization versus global optimization. Local optimization, how can I save this money? How can I save this time? How can I save this particular activity from spending as little time and money as possible? Global optimization as an organization or as even a product we are developing, how can I minimize the overall cost of developing this product? So one thing we realize quite often is if I intensify the rigor in certain areas where that's necessary, it actually reduces the time and the cost in other areas. And I think that is the senior members of your organization have the maturity to understand this. But sometimes, in all honesty, it is also the junior members who need to really bring these topics for a discussion. Uh, Maybe I was way too fortunate in my life. Maybe this is pure coincidence. But in every job I've had, when I got out of school, is I never felt I was under this whip of my managers where they said, you will do this or I'll fire you. Instead, oftentimes, except for maybe few different occasions, for most part, it's been a conversation where my boss would or my director would come to me and say, I want to do this. And the expectation in saying that was not compliance, but a conversation. I think that was a distinction in the teams I worked in. So when they say I want to do it, it was not where I say, okay, boss, I will get this done. Instead, to have a conversation to say, wait, you want to do this, but let's talk about the consequences of this. And so when we left the meeting, we almost always left the meeting changing the plan based on the reality rather than being denial about the reality and sticking to a plan because they said so. I think the key here, to come back to your question, is to really engage in better conversations, I think. Because as a manager, as a director, if you come with a question to the team rather than a command to the team, I think we have much better opportunity to reduce the risk. So if you say, hey, with all this LLM, we can go faster, right? So what do you think? Can we accelerate to this extent? This is what I want to achieve, and see what the team comes up with. And you have a set of people who are competent, capable, knowledgeable. And if they say, here is practically what we can do, we cannot achieve the amount of productivity you claim or you desire, but we can achieve to a certain extent higher productivity. But here are the things we need to do. That's one option. The other is um, take the time to evaluate and learn from the failures. I think the biggest failure for us is not learning from the failures. Einstein said the definition of insanity is to do the same thing over and over, but expect a different result the next time. How many times do we notice this? We failed miserably, we didn't succeed. Okay, what did we learn from it? Did we learn the right things? Are we making the right changes so we can get better at what we do? I think it is really taking the time to learn from the failures is very critical, especially in this stage in the evolution of the tools and techniques. Learning from that failure is more important than anything else.
That's such an interesting take. And hearing you describe the conversations that are normal and healthy in an organization, I can't help thinking how polluted the conversation has become because of this insane pressure and insane hype that LLMs supposedly deliver um, increased productivity, and then there's the fear of not only missing out, the FOMO, but the fear of being left out of the race that pollutes the conversation to the degree that it's become toxic in many organizations. I wanted to ask about AI and the thinking behind working with LLMs as a software engineer from a different perspective. So LLMs have been compared, in my mind, almost incorrectly to compilers as English being a higher level programming language, which is not, because English has metaphors. You cannot be completely precise. It's a programming language does allow you to precisely specify what you want, but that's a different conversation. The comparison between LLMs and compilers has been going on for a few years, ever since LLMs became borderline useful in software development. But I want to tie this comparison between LLMs and compilers, to the threat of LLMs being not necessarily job losses, but cognitive decline. And cognitive decline meaning that as reliant as you become on LLMs, you lose your muscles of thinking that we have worked so hard to train. Um, so I wanted to ask about this idea, and how was it in the past when compilers came to the industry? Was there any threat of cognitive decline for that reason? Because programmers no longer needed to work on assembly code or bytecode or whatever that was. How do you compare, or how do you see this whole picture?
I actually would say that LLMs or AI doesn't automatically lead to cognitive decline. I want to emphasize that. It is the person who is using it brings upon themselves to have cognitive decline. I'll give you a little anecdote before I get back to the compilers versus LLMs. I was driving the other day, and we all can agree, right? We got calculators today. You can punch in numbers and you can get results. This argument is more akin to calculator being introduced than compilers being introduced, in my opinion, because compilers didn't force as much cognitive decline as we feared as calculators would have. But my argument really is, I was driving the other day when I got a call from the office, and they were talking about a particular financial deal we're going to make. And well, here's the amount. Here's a 10% discount we're going to be getting, or whatever percent of discount it was. And after the discount, here's going to be the amount. And I'm have my hands on the steering wheel. I'm driving, right? While I'm listening this through my audio on the car to this conversation. And I said, hang on a second. You mentioned a few numbers. I want you to go through those numbers one more time. And then they repeat the number. And I said, I'm sorry, I'm not near a calculator to run these numbers, but I have a feeling these numbers don't match up. Can you please take a look at it one more time? And then there was a pause, and they said, yeah, you're right. We got this wrong.
Oh my
Let's go
God.
ahead and fix
Wow.
it. So the point really is that if I am completely blind to recognize that things don't match up, so to me, the most important aspect of a human being is critical thinking. If I don't have critical thinking, and it doesn't matter what I do, because it's not just the tools. Even a kid will be better than me with the better critical thinking than I would have. So it really comes down to not letting go of the sense of that critical thinking. And so did calculators or computers, I'm sorry, compilers for that matter, really dumb us down? And the answer is really no, because we still need to know what we need to know, what these tools removed from our hands. And I often make this comparison to LLMs to compilers for a reason. And the reason here is that compilers did not eliminate programming, compilers reduced the tediousness to programming. And I often give this analogy of you could hire 20 people who are going to be using shovel to dig a hole. And sure, in a lot of parts of the world, people still do that. Or you can hire this one person who can sit on the top of a crane and press the buttons and dig the hole. Now, I would argue that the person who was digging the shovel, with all respect, is low skilled compared to the person running this crane. If the you don't want me to be on that crane, you're going to have really big damage if I was on the crane. The person operating the crane requires a certain amount of training, certain amount of discipline. They need to also understand what they are doing as well. How deep can you dig? What is under that place? Am I going to be damaging pipes and gas pipes potentially if I'm not digging properly in a location? So these things are not removed when you use a crane. It's the same concept. When you're writing if you ask me, this pains me. I got my degree back in the 1990s. And when I went through my college, I had to take course on compilers. I never had to write a compiler for a living. I never had to do assembly programming, except I did a few things in college to do that. But in the past about 20 years, one of the things that pains me is most universities got rid of a compiler's course. I can't tell you how sad I was when I saw that happen. So the reason for me became sad is there is this saying that you should always know about at least one level of abstraction below the level of abstraction you're working in. That is very critical. So I may not write code in assembly, but I need to understand what is happening at the machine level for me to be able to understand that level of abstraction. How does memory work, right? So a course on data structures, a course on compilers, a course on computer architecture has been enormously valuable in addition to algorithms and what have you. So to me, yes, we can start using LLMs, but that is not a reason to abandon the learning one level below the level of abstraction. I need to be able to evaluate what is being created. If I don't have a sense of how to evaluate and verify and validate, then it's garbage in, garbage out. I have no clue of evaluating what this is producing. I'll share with you one experience that absolutely shocks. Um, I also part-time teach at the university, and this is a story I heard recently from one of the courses I've been teaching. This is a group project, and this is where it comes to critical thinking and knowing what you're doing. And this particular team has been working with a team member who has been falling behind, and they were like, "We got this feature to be completed. Why don't you work on it and get this done?" And this person has been postponing. And then finally they said, that's it. We need this on Monday. We cannot delay this any further. And this particular student said, sure, I'm done with it. They're like, Thank goodness. I'm so glad you're done with it. And so let's integrate this. Can you give us the code? And they received the code, and the entire project was in C sharp and TypeScript. And the code that the student produced was in Python.
Wow.
And they went to this person and said, "We don't understand. You just gave us a Python code into a project that has TypeScript and C sharp. Can you explain what's going on?" "Oh, no, 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 no. This is correct because AI generated this." Well, the person didn't even know that by default, if you don't say what language to use, it's going to spit Python code back at you. This is not the problem of LLM, not a problem of AI. It's a lack of the basics of thinking. You don't even know to recognize what code is generating because you're so eager to move forward. And to me, and again, this was a student who didn't think about it, maybe was in a frustrated situation, but amplify this all the way to developers who are not focusing on what they are producing, but in clicking buttons. That's like hiring a crane operator who is completely illiterate, doesn't have any idea of quality and consequences. Well, I don't think they're going to be getting off the crane without causing sufficient damage. So I think this really requires a proper amount of training, if you will, in a sense, right? So essentially, what this really boils down to is how much of uh, responsibility we can take when using these tools really becomes the necessary question in this case. And if I don't care about what I produce, and I'm keenly interested in just focusing on using the tool to create garbage and move forward, I think we're going to be in a much bigger risk in this industry. Uh, Again, I emphasize this is not a problem of the tooling; it is a problem of the person using the tooling, and I think that's not something you can avoid by reducing the use of tool, but I think you can address it by more education and awareness. And maybe even more collaboration. When you're working with somebody who doesn't have that sense, maybe the question here is, how can we help them to develop that critical thinking? How can we help them to develop that thought process where they begin to really evaluate what they are producing rather than just merely using the tool?
I wanted to segue this to the kind of patterns that now, I mean, in the modern day and age, we as software engineers have kind of changed over time. Um, for example, design patterns like the Gang of Four and things that were gospel a decade or two ago. I wanted to ask, let's just say Gang of Four, is that still relevant?
I'm gonna generate some heat by saying this. I don't think it was relevant even before.
Hmm.
And I'll tell you why. If you know anyone gets a chance to look at my design patterns talks on YouTube, I always start with this in my design patterns talk. I often say design patterns are the worst to create any sensible design. I always believed from experience that design patterns are fantastic communication tool. They were never a good design tool. So I can't answer whether they're still relevant because I don't think they were relevant even before as a design tool. I think they're really good communication tool, but not good design tools. But having said that, I would say that we will have to rethink about design principles, design patterns, code quality, all of those we need to rethink about it. The reason is most of us don't care about the quality of the assembly code. And I would have to emphasize that people writing assembly code care about it. People creating compilers care about what they generate. So at some level, there is need for good quality of those generated code. But if I consider the code being generated as an implementation as a black box, I don't have to look at the code that's being created. as long as I can very clearly verify the input to the output and behavior, then I don't care as much about the quality of the code that is being created internally. Now, when I say I don't care about the quality, I want to emphasize what I don't mean is I don't care if it doesn't perform very well. I'm not saying that. I'm not saying I don't care if it uses too much memory. Those things are still important. But the way I would emphasize that is by providing proper test cases. As an example, one of the things I often recommend to teams is if you care about performance, write test for it. That's one thing I've been emphasizing for a long time. So if I care about a certain behavior of the code, maybe I'm realizing the memory is not adequately being used or not being optimized properly, or the performance is not adequate, the scale is not there. Well, I would have to put those constraints and verifications to verify the code generated serves those purposes. So to come back to your main question, I think that we are going to redefine what these qualities mean. But again, to emphasize this, I've been working with teams where I go to them and say, my gosh, this design looks so complex. Why do you do it? And it pains me to hear them say, oh, I wanted to use these design principles. I was using solid principles to do this. Well, yes, we could be using principles in the wrong way and get bad results out of them as well. So it's not that these solid principles or design patterns or quality metrics were all, guiding us in the right direction all the time. It still were, so to say, tools in the hands of the right person. But I think we're going to redefine, re-understand what these quality metrics are. I think it's a little too early to know what that is, honestly. But having said that, there are certain things I think we can agree upon. There are certain things that shouldn't be done with an implementation. Unfortunately, LLMs don't know the right from the wrong. So we may have to provide guidelines as to, I don't want you to be doing this. I don't want you to be creating a shared mutable variable and hacking them through in your code. Maybe we'll start providing those kinds of guidelines along the way rather than focusing more on a particular design pattern or a design principle, because those things were really intended to help the human programmer more than a tool that can deal with it. We suffer from cognitive load. AI has no consequence to cognitive load. I have taken some unbelievably extremely hard code that almost no human can understand, and AI just spits it out and says that's what this code is doing. So I don't think we need to really be providing the metrics that we used to rely upon as a metric for AI to be following. Absolutely not.
So there's this recurring idea that now that we started talking about design patterns, there's this conversation and a theme in the conversation has been that if you need a design pattern that's just a language feature that you're missing, where do you stand on that? And how have you seen programming languages embody some of the principles that design patterns wanted to teach in a good way?
Totally. I often say that a design pattern is a sign of deficiency in a language. I've been programming in C++ for a few decades before I shifted to programming in languages like C# and Java, and certain design patterns I would be using in C++ became completely redundant in Java and C#. But then certain design patterns in C# or Java were totally redundant in Python or Ruby when I started programming in those languages. So to me, a pattern is a way to, compensate for something a language is lacking quite a bit. In a similar way, when lambda expressions were introduced in Java, I was making fun of that to say, I would be spending, effort writing strategy pattern. Now we just call it a lambda. So because lambdas can be passed around to functions, so essentially a strategy becomes a lambda rather than an interface and a bunch of classes we had to write using the object-oriented styles of previous versions of Java. So to a great extent, I do completely agree with that. that better a language is, more evolved a language is, the less we would need patterns because they become common natural features in the language. So it really becomes a capability of a language rather than trying to put things together with the lower levels of abstraction to where we want to go with it. But that also leads to a bigger concern is what if the future programming languages are not human maintainable programming languages, but machine maintainable programming languages? I don't think at that time it really matters as much to us about patterns in general again, because it's the machine that's going to be dealing with this code. And it doesn't matter to us what these patterns really are from that point of view.
Do you have a language that you think has landed on your style of thinking particularly well? So you've programmed in Java quite a while, for a long time, and obviously C# and the .NET before that. Um, just to make the question a little bit more concrete, uh, the evangelizing of functional programming in Java kind of mostly worked because over the years, Java has increasingly integrated functional style in the language, like lambdas, immutability, streams, and now kind of like algebraic data types, but in a toned down way with the Java features. Where are you on that in the sense of language features that are particularly well suited to your style of thinking? Has Java landed that? What is missing, and what would you like to see in mainstream languages?
I think one of the challenges really is that almost never a general purpose language is going to really meet that expectation entirely, because they are exactly that. They are general purpose. I've spent enough time in Kotlin, and I often say that I define Kotlin as a cocktail of programming languages,
Cocktail. Good.
because I've got people come to me and say, "Ooh, I'm looking at Kotlin. It reminds me of fill in the blank, Python, Haskell, C sharp, Ruby, and Groovy. And you can endless number of languages. And every one of those statements is true because the creators of Kotlin literally did that. They went kind of shopping and they said, "Ooh, I like this, I like this, I like this." And they, in a nice, hygienic way, brought those features into the language. So you could say Kotlin kind of comes a bit close to that because it's really built on the features that a lot of languages have had over time. Languages like Scala all the way up to Haskell and even Erlang. A lot of those things you can see in Kotlin. But having said that, one of the things that really excites me is that this idea of continuous learning. And that is what is the beauty of the field we are in. We are never done. When we finish accomplishing something, it opens up this space where you feel there is so much more to learn and so much more to really excel in. And Personally, I'm more of a hybrid language programmer than a functional programming language or an object-oriented programming language. This is where it gets a little tricky. When I program in Python, I program very differently in Python compared to when I program in Java. And I have to say, I'm almost home with each one of them by their own trait. I am not the person who normally programs in one language and complains that things are better in the other language. So to me, a language is not a choice in a lot of situations I'm in. I'm a consultant, so I work with a lot of different teams. So I get drawn into projects where somebody may be using a C sharp on one project, Python on another one, and a Java or a Kotlin on and a third one. And I need to be able to provide the maximum benefit for them for the language they are using. It doesn't help me to walk into the building and say, you guys should be really using this other language. So the question to me often is, how can I exploit the features of the language I'm programming in to get the most out of it? And having said that, I do feel that Java has been evolving in a very sensible manner for the past several years. I was that guy on the other side of the picket line complaining that Java is not moving forward. We should abandon, we should never ever program in Java again. But that was in 2010 timeframe. But once Java decided to move forward with the 6 months release cycle, I am looking at where they are going and what features they are really looking at. And I do have to say that I'm pretty excited about where the language is heading. One of the things that the developers behind the Java language are doing very well is the Java language doesn't have the luxury of doing things and saying, oops, that's not an option. Because when a language is being used by such a wide range of organizations and they rely on, in all honesty, they rely on stability more than anything else. You don't want to go to a large insurance company or a large bank and say, we did this, but now this won't work. You got to change it. That's not going to be very welcoming. So they are very cautious in the way they are developing, evolving the language. And I would give credit to a lot of other languages, Scala and Kotlin and various languages even outside of the JVM. And the folks behind Java are very keenly observing these and learning from these, and then asking the question, it works really well over there, but how can we make it work within the JVM for the benefit of the developers using the Java language? And they're not infatuated by the features. That's what I respect of them. They're not keen on saying, let's rush to bring features in. Instead, they're asking a very deliberate question. Is this useful, first of all? And how much benefit do we bring by adding this? Is it a marginal benefit or is it a significant benefit? And one of the other troubling question, hard question they're asking is, if we introduce this feature now, what feature in the future would become hard to introduce? That's a more difficult question to answer because, if you look back in the history of Java, you can put your finger on one feature of Java that's made almost all the other features that came after that much more difficult. And that feature in Java was serialization.
Hmm.
Serialization made life hard for everybody who came after that. So that's a question you want to ask. What am I going to do today that's going to make the life of those coming after me more miserable and difficult to introduce and evolve the language? So to me, as a programmer, my life is a lot easier than a language author or a language maintainer. I remember Brian Getz, the chief architect of Java, say this. When you write program, you are worried about one application. When you write a language, you are worried about every single program in the world. So that's an enormous burden for you to carry forward. So I think the language is heading in the right direction. There are a few things they're working on that seems to be exciting from where they are looking at. Personally, for me, I have worked in applications where we've been bitten by performance issues, not because the code was running slower, it's because the garbage collector would kick in, and eventually we just have to wait for the garbage collection. In one application specifically that I worked on, we were auto boxing so much of double into the memory, we got really hit by the garbage collector. And so to me, the feature that I am really looking forward to, honestly, is value types. And if the data can be kept on the stack and it can be thrown away at the end of the stack's unwinding, I think we will have an enormous benefit in terms of performance. Mix that with generics, where generics can use value types. I think that's where we're going to see the maximum improvement. In some of the applications I worked on, I think we're going to see a huge benefit in having that particular capability. So that's what I'm looking forward to personally on the features, looking ahead, if you will.
I have a couple of follow-ups to this one. Uh, I can, I'm just going to pick one. Um, what is a feature that you like in Java, and specifically praise it because it's invisible. And the way that I'm framing this question is a lot of improvements to the Java ecosystem have not necessarily been so much front facing to the programmers themselves, because the language itself hasn't changed all that much, but the underlying mechanism has changed by quite a bit. Um, is there a piece or is there an example that you particularly appreciate in that sense?
Oh, hands down, I have one, absolutely. Let's go back to 2008, if you will, for a minute. 2008, 2009, maybe even 2011, before the days of Scala 2.12, if I'm not mistaken. So the time when both Groovy and Scala had lambda expressions, but Java did not have. So when I write code in Scala or when I write code in Groovy, those lambdas would get converted into anonymous inner classes.
Right.
So if you compile your Scala code, you look at the bytecode being generated, you have all these classes generated for these lambdas as anonymous inner classes. And when the folks behind the Java language were working on implementing lambdas, the question immediately was, how do we implement lambdas? And they could have taken the obvious route, right? Hey, lambdas are anonymous inner classes, end of story, let's go home. But instead, they were sitting and struggling with this and asking, how can we make lambdas take very less footprint? A programmer is not going to see this, right? Because a programmer is going to see the syntax, but this is what's getting generated at the bytecode level. And they came up with this. So a little story behind this is when they were working on Java 7, there were a few people in Oracle who really wanted to improve the performance of languages like Groovy. And so they were asking how, as it turns out, for calling functions at the bytecode level, there were only 4 instructions. There was invoke static, invoke private, invoke interface, invoke virtual. And they really wanted to see how to really make these languages more efficient, like languages like Groovy. And as we're struggling with this, they came up with a new bytecode instruction called invokeDynamic. So invokeDynamic, the history is invokeDynamic was created to make languages like Groovy faster. And once they had that in place in Java 7, as they were working on lambdas in Java 8, which was more of an extension of Java 7, they were struggling to see how to implement lambdas. And somebody said, wait, what if we hijack invokeDynamic, and rather than making it a feature for languages like Groovy, what if we make it as a primary feature for Java to implement bytecode? That was a phenomenal change. So this was a completely different use case. So they had to rework invokeDynamic in Java 8 compared to Java 7. So when you write a lambda expression in Java, it literally becomes a function rather than being an anonymous inner class, a method within a class. And the call to it is dispatched using invokeDynamic. Nobody would have guessed back in Java 7 that invokeDynamic would be a feature that Java is going to heavily rely upon. I would say that's one of my most favorite feature that you don't see. It's not visible to you as a programmer, but makes a huge difference in terms of the memory size, the footprint, the performance in almost every single angle. Reduce garbage collection. The less garbage you create, the less garbage you collect. So overall, I think it's one of the most important implementations in Java in terms of what you don't see, but it saves your day. And as a matter of fact, when Scala evolved to a future version, they decided to embrace that idea. So in the modern Scala, for example, you don't have anonymous inner classes for lambdas. They are literally, generating the bytecode for invokeDynamic. that is thanks to that effort from Java. But truthfully, more than a Java language feature, it is the JVM feature that really made Lambda implementation much more practical on the JVM.
Very cool story. Any new ideas that you see or saw in recent programming languages that you found particularly creative or useful and worth integrating into the more mainstream?
There are bits and pieces of things I keep seeing and getting excited about. One of the things that I really like in TypeScript, I have a different view of TypeScript than a lot of people do. People get excited about TypeScript for totally a different reason than I get excited about. I'm not a big fan of static typing per se. Static typing is valuable, but I would say I gain a lot from the ability of the compilers, but compilers are not flawless. They're still going to allow you to create, code with bugs, if you will. So I don't put that much emphasis on it. But one thing I do like about TypeScript is really their ability to uh, take a data or a structure of data and then to be able to infer that as a particular type. I think that's a really brilliant way of thinking about it. So to me, this is a nice bridge between the dynamic world we live in and then the code where we are trying to treat things as a certain objects. I think that's really a nice way to bridge the gap between things, if you will. Um, One of the other things that I absolutely blew my mind is looking at the Elm language. Elm is fascinating to me because Elm is 99% Haskell syntax
Mhm.
and maybe a little tinge of F sharp syntax in it. So it's Haskell with a tinge of F sharp, but scary, it compiles down to JavaScript. But what blew my mind with Elm is knowing that I'm writing code in Haskell, but knowing it's running as JavaScript really gave me a pause to think about when you program in a language like Haskell, you honor immutability a lot. You don't do as much of that in JavaScript, but programming in Haskell fundamentally helped me to rethink about how I can approach immutability, even in a language where that is not a primary focus. So I think that was quite brilliant because it gave me the opportunity to rethink about how I can develop applications with a sense of purity in mind and try to really push immutability as a set of transformations rather than mutations. And I think those things really excite me. So I think more than languages per se, I would say maybe partly some of these are language features, but also more so as a frame of mind for me in terms of how I would approach programming in these languages rather than what the languages themselves may provide, if you will, might really help as well.
Um, that was such an interesting take. I wanted to ask now that you've spoken about immutability, there are there's a spectrum of positions to take on immutability. I'm personally a Scala developer, and immutability is very valuable in the ecosystem. Other people don't value it as much because it makes the code slightly more complex. You have the downsides of garbage collections and unnecessary allocations and whatnot. And there's an in between, which is immutability in the front-facing API, but allowing mutability in the back end so that you can maintain kind of the best of both worlds. Where do you sit on that?
So to me, there are two reasons to really focus on immutability. One is the human aspect, and the other is the system aspect. And I think it's important to recognize the two aspects independent of each other. For me, the human aspect is immutability makes it easier to reason about the code. That's something I appreciate. I can't tell you how many times I'm looking at a piece of code and I lose track of what the state of an object is or a state of a variable is. Doesn't even have to be an object. And that's when you pull out a paper and you're trying to really note down what the state is. You're trying to really go through an enormous, painful debugging process. So immutability makes it easier to reason about the code. That's one aspect I really enjoy. But the other aspect that I think is very critical to keep in mind is the system aspect. And that again comes in two flavors. One is immutability becomes essential for things like lazy evaluation. So if you're doing functional programming, I often say immutability is not a fashionable thing in functional programming. It's an existential crisis if you don't have it, because you cannot have lazy evaluation if you don't have immutability. That hinges on the correctness of the code. But there is a bigger benefit also. Compilers are able to perform better optimization when you have immutability than when you do have mutability, because referential transparency comes in when you have immutability. So compilers tend to optimize code. You get better performance as well in the end because of that. But having said that, the issue here is we tend to focus on mutability versus immutability as creating more objects and having to maintain more objects. But as it turns out, there are data structures like tries. For example, a vector implementation in Scala is a good example of that, is where the implementations can be guided through creating only variations of the data rather than keeping full copies of data. In a way, you could think about it as look at a Git repository, for example, or any version control for that matter. These don't mutate files as you commit them. Instead, what they do is they only keep the diffs. So it's a question of maturity of data structures in my mind. So what if we can keep diffs of the data change rather than having to make full copies of objects? I think we can hit a good balance between performance, reduced garbage collection, and better maintainable applications, performance, scalability, potentially reasonability, ability to reason about the code. Uh, I think one of the challenges I often, as a critique of languages, often I say that when languages take a unsafe default versus a safe default, if you look at languages like C++ and Java and C Sharp, predominantly I would argue they have favored unsafe defaults. Final is not the default. Mutability is the default. For example, you can override classes, that's a default. But when you look at languages like Scala and Elm and Kotlin, and they favor safe defaults. Val is the default. Your function parameters are immutable. That's the default. Well, that's not only the default, that's the only way it behaves in Scala and Kotlin. And so generally, I think we as programmers find it enormously hard to uh, wrap our mind around a certain way of writing code, not because that is more complex. It is because that's so different than what we are used to. But on the other hand, if we are starting out with that mindset, it probably is a lot more easier for us to accomplish it. So this is more of a journey of the programmer than the programming or the languages themselves in terms of how effective we are in embracing immutability in general, I think.
How should a programmer practice good thinking patterns? Uh, this is a broader question, but throughout this podcast, I've had many guests who are have many decades of experience, and they all talk about this this ability, this discretion ability, this critical thinking. You named it critical thinking. Other guests called it good taste. Other guests called it intuition. Other guests called it wisdom. I tend to I tend to think about all of these as pretty much the same concept that can only be grown by experience. But I wanted to ask you, how could a programmer in this day and age develop that skill, good thinking patterns, especially at a time when, to go back to our earlier LLM conversation, at a time when the typing of code is no longer that relevant, or when we're not striking keys on the keyboard as much. How do you think about that?
I'll tell you a phrase that's become my very favorite phrase because that's a phrase that keeps appearing in my mind over and over and over. When I write something, the phrase that pops in my mind is, there's got to be a better way.
Hmm.
And I cannot tell you how much I appreciate that phrase when it pops up in my mind. I write something, whether it's a code or it's a chapter or a blog post or even a tweet or a social media post. The minute I write it and before I let it go, my mind says, there's got to be a better way. And to me, having that question pop up in your mind is the first step because I can tell you how many times people write stuff and they just push it and they walk away and they don't even look back to say, is this good enough? Can this be better? And so there's got to be a better way. To me, is the phrase I want to emphasize. So as a programmer, if I can look at something, I'll share with you an experience that I would probably never forget. And this is by no means an insult on anyone, but just to narrate my experience, a company that I used to work for, they purchased another company and they were going to integrate these two companies together. So my boss comes to me and says, hey, why don't you go over, talk to the developers over there? They're across town, get to know them a little bit better because in a couple of months from now, you're going to be working shoulder to shoulder with them and you better get to know them. So I drive across town, I'm sitting there, and this developer is opening the source code. And then he's telling me, I'm sorry, hang on a second. I got to make some changes before I can run this code. And in front of me, he's making some changes. I'm sitting right behind him and watching him. This is the first time I'm ever seeing this person in my life. Never seen this application they're developing, know nothing about it, but I'm sitting there and thinking, there's got to be a better way, right? And I didn't tell this to him, but I'm like, there's got to be a better way. I can bet you there's got to be a better way. Fast forward 4 months later, I am working on that code base, having integrated into that company, right? They put me on that project. I open the source code and I'm like, oh my gosh, before I can execute this, I got to make these changes. And the first thought in my mind is, heck no. And I spent 2 hours trying to figure out what the problem was, fix it because I'm so angry. And the developer comes over and says, what did you do? I said, well, I had to make these changes and I find that this is so hard. So I made this change. And he looks at me and says, my gosh, I wish we had known this 2 years ago because we've been struggling with this for so long. And to me, I may not know the answer, but I know the question and I know the problem. And I think the first step in solving any problem is identifying the problem. And that's what I would say. You don't need to be the smartest person in the room. You don't need to know the answer, but you need to know the frustration. I think that's the key, right? So to develop that sense of there's got to be a better way is my first step. Because the minute that question raises in my hand, I am there digging deeper, looking for solutions. I may not find that in the next hour. I may not find that in the next day, but knowing that it's got to be better is driving me to find a better solution, a better answer, to find something that's superior than what we may have created. But at the same time, also, the little caution here is to not go overboard with it, right? We're not going to this analysis paralysis and then keep tweaking things to no end, because at the end of the day, we still need to release products and move forward as well. But I think in general, to have that sense to ask the question, is this good enough or can it be better, has been a driving force for me.
Very cool. Uh, Even just this one thing can push you to ever better levels of performance in general, including in this discipline. This is great. I love it. Uh, w- Now that we're on, I'm going to take this as a personal piece of advice, by the way. So I'm going to note this down. I'm going to steal this idea. This is going to be this is great. What are some pieces of advice that you've delivered to other people? Because obviously you've mentored thousands of developers, you've spoken at conferences, you've consulted countless companies, you're a professor, and so on and so forth. What are some pieces of advice that you give to people that is generally acknowledged? Like, yes, Venkat, you're great, this is perfect, and then they completely ignore it.
A lot of stuff is in that line. But I'll share with you one experience that I feel where it was truly fruitful. Um, I've done training on automated testing and test-driven development to several organizations, several teams. I do have to say, for a lot of those teams, they have like, yeah, great idea. We're not going to do it. So if you ask me what's my success rate from those trainings, I would say pretty low. And the reason it's low is people begin to realize this actually requires work. I've named this mindset as agile by convenience. And what I mean by agile by convenience is I believe in agility, but I want to do things that are convenient. Oh, standard meetings are awesome. It doesn't cost me a whole lot. And other rituals we come up with, easy ones to do. So we do these because they are easy to do. But to me, to be able to sustain agile development, we require the engineering rigor. And a lot of companies are eager to learn those, but they rarely want to follow it. But having said that, I had a company in the UK call me and said, can you come and do TDD training? We've heard about you. You came with high recommendation. Can you come and do TDD training? And I remember this was like 4:30 in the morning, my time here in Colorado, and this person from UK is talking to me, and I said, "Hey, would you mind if I come down there but not do the training?" And he said, "I'm completely confused. Why would you want to come here and
No
not do the
wonder.
training? Because because we are asking you to come down here for the training." And I said, "Let me be absolutely, frank with you. I can do the training. Absolutely, I can come and take your money and do the training. But I can bet you when I finish the training, your developers are going to say, Venkat was awesome. This was a great course, but we're not going to do any of these. So what's the point in you hiring me when they're not going to use these things?" He was like, how are you so confident? I'm like, I'm confident because I'm telling you from the data. I've seen companies use the training and do nothing with it. So he's like, what do you want to do? I said, forget training. Let me come and just absolutely pair program with your team. Give me 2 weeks instead of 1 week, and I'll sweeten the deal for you. I'll charge you for 2 weeks exactly what I'll charge you for 1 week because I really care about the result in this case. And he said, I'll call you back. I'll think about it. It takes about 2, 3 weeks, gets back to me and says, okay, deal. We have decided to move forward with it. When can you be here? So I go there, sit shoulder to shoulder for 2 weeks, and I pair program with them. And at the end of the 2 weeks, I said, thanks for having me. Best wishes. And I walk away, as I normally walk away from teams. 4 months goes by, and I get an email from this person saying, I just found out you're in UK next week for a conference. Can we steal you for half a day to come visit our office? Oh, I would love to meet the team again. Absolutely. Thanks for calling me. So I go there and I'm like, what's up? And they're like, we didn't want to tell you anything before you came in here. We wanted to show you what we have done in the past 4 months. I was almost in tears when I was watching them because at the end of the 2 weeks, they realized how important and how practical it is for them to do it. And they had gone on and done test-driven development on their next application they were just starting. This was one of the most successful opportunities I've ever had. So while most people would say, yeah, great, but that's not for us, this team really took it to to the heart, and they went on and implemented it. And that to me is truly my, moment when I feel good about what I do because you're going to do work, you're going to make money, you're going to accomplish things, but what is the result of it? The result is not people saying that was a good course or a good training or a good consulting. To me, the result is when people have gone on to make changes to what they do and have done things better. And does it happen all the time? I wish I can tell you yes, but it doesn't. But when it does happen, I think that's the most rewarding opportunity.
I I find this fascinating. So they offered you a training gig, and you said no. I'll come for 2 weeks and just embed myself into your team, which is far more than a training. And you sit there for 2 weeks and you charge them the same. So you basically gave them a much improved service. Nobody does that. How I wanted to ask about this approach, this thinking process. Uh, has this been developed over time? Is this native to you when you land any consulting or training gig? How does this work? I'm curious to how you approach this sort of conversation and how you make these sort of decisions. Because when you when you spend 2 weeks instead of one, that's 1 week that you could have spent in some other training and people would have praised you just the same and so on and so forth. I wanted to ask you about that. How did that come to be?
So this actually, you are kind of directing me towards a much deeper philosophy,
I care about that.
uh, which
This is why I'm asking.
which I embrace. So I have this philosophy, and a bit troubling because I think a lot of people may not agree with it. But the philosophy I follow is this is for anybody, everybody, in my opinion. Pick a number. I'm going to pick a number 40. 40 years of age is when you quit working because you need to and you start working because you want to. That's my philosophy in my life. Uh, 40 is the cutoff for me. And at 40, if I stopped working, I would be fine for the rest of my life. I don't need to work anymore. And so from then on, and that's been roughly about 28 years now. Or actually 18 years. I'm doing a math wrong. So about 18 years, maybe close to 20 years now, getting to that point. Um, I realized that I don't have to work in order to continue to live comfortably. And so one of the benefits I have probably is I don't work for a big corporation where quarter to quarter profitability becomes absolutely a critical factor. If I make money, I'm happy. If I don't make money, I'm as happy. Doing stuff is more important to me that provides value than to just bring in revenue. And so that mindset really shifts the way I want to think about things. And again, it's not like I want to just do free things and go away, because you want to make sure that you do provide value, and for organizations to gain value, they also need to take responsibility to pay for it. But at the same time, it's to me the real concern in my mind is it is not what I deliver, but what value I create matters to me. So it's the outcome, not the effort. So this is again going to the philosophy. Don't work hard, but work smart. When somebody says, "Do you know how much time I spent last night?" I'm like, with respect, it doesn't really matter, because you could have spent your effort doing things that are not necessary. You could have asked for help much sooner. So to me, being smart about what we do rather than just working, blunt force in working doesn't really, excite me. So it really is not driven by money. At the end of the day, there's not a whole lot I'm going to do with all the money that is there. The, the, again, going back to philosophical thing, they don't let us take the money eventually. It's got to be left behind here.
Mm-hmm.
So there's no merit in acquiring more wealth than essential in general. So by working an extra week in another company, delivering less value is going to increase my bank account, and I'm going to do what with it? I don't think I need anything more than what I have. So I might as well spend time doing things that will help me sleep better in the night rather than having a bigger bank account, I think.
Admirable. Oh, all the more admirable for somebody in your position who can land pretty much any opportunity, really. I wanted to ask about your speaking career, because you're also a prolific speaker. I'm guessing that also ties into the value that you want to create, because you want to impart much of your knowledge to as many developers as possible, given the fact that you are a passionate programmer. So, first of all, how do you keep the ideas fresh throughout many conference talks if the conference talks themselves cover variations of the same core ideas, like I don't know, the core principles of programming, immutability, you name it. How do you keep these ideas relevant, and how do you tailor your conference talks to make them evergreen?
One of the things that I've realized over time is uh, it's not about the speaker, it is about the audience. As a speaker, if my goal is to show what I know, I'll end up failing because the audience are not there to, figure out what the speaker knows. The audience are there to figure out what they can learn so they can go back and apply. And to me, a lot of frustration comes from my own inability to learn when concepts are unnecessarily complicated or uh, presented in a way that it's not easy to digest. And as an example, when I came across reactive programming, I was like super excited about reactive programming. I was like, oh my gosh, what is this thing called reactive programming? And I started reading through a lot of material and tutorials. And the immediate reaction was frustration because this was a lot of hand waving. It can do this, it can do that, it can do this. And here's how you build architect. You architect the system, you design the system. I'm like, show me the damn code. How do we get this working, right? And it was very frustrating for me because it was not digestible. It was not something I can, spend 15 minutes on and say, good, now I can put this to use. It really puzzled me. So I said to myself, what if I start writing code and bringing these ideas into it? And I spent maybe a couple of weeks to a few months just playing with this from the programmer point of view. And once I learned about it, I felt like I had a story to tell and I had something to share. So, pardon me, a lot of times, what I really focus on is the journey from the point of view of how I would like to learn about a concept rather than how I like to teach a concept. So to teach something, you focus on what you want to deliver. But to learn something, you focus on what you want to be presented in front of you. So this is one of the biggest distinction in my presentation is I often think about me, the student, and what do I want to learn and how do I want this to be presented. If a speaker stands up there and starts presenting large ideas, I immediately get lost. And the minute I get lost, there's no interest in me listening to this talk any further. And that becomes a waste of time. But instead, if they are able to walk me from one step to the next in a way that I can follow, it becomes a lot easier for me to go through the journey. And the second thing I also find oftentimes very intriguing is that this goes back to the discussion we had earlier. I'll give you one example of this. To go one level below the level of abstraction is very helpful. So oftentimes when I'm teaching something, I would open up the bytecode and say, this is how it looks in the bytecode. So to give an idea of how this is being represented, either conforming to certain ideas or maybe showing the opposite of that and saying it's okay to be different in this layer, whereas this is the abstraction you're getting. But to get the depth is very valuable in my opinion. So I tend to often do that is really dive into lower levels of abstraction without losing the audience, but to give relevance to it becomes really essential. But one of my aha moments was I wanted to really show how Haskell was implementing, calls to functions, a distinction between applied, a normal function call versus an applicative order versus normal order. And I was kind of, stuck with it because how do I show that Haskell doesn't call a function? You can show that it calls something, but how do you show it doesn't call it? And unfortunately, you can't put print statements in Haskell because Haskell, enforces purity of functions in this particular case. And if you make it impure, it defeats the purpose. So I was kind of sitting there and scratching my head. How do I really illustrate this to the audience? But it really came back to the question back to me as a student. How do I tell myself this is what it's doing? How do I prove this to myself? And I never thought I could do this, but I figured out I could actually use the debugger for Haskell and put a breakpoint into a function and know that it's hitting the breakpoint or it is not. And so that to me became a way to illustrate a certain concept. So this goes back to the show and tell idea. So a lot of times we are interested in telling how things work, but I think it's as important not to just tell, but to also show as well. Because if you're able to show, then you are grounding those ideas a lot deeper in your own mind, and then in the minds of those who are learning with the concepts as well. So those are some of the things that I tend to really follow is, how do you get deeper into appreciating these ideas so you can actually see them and not just assume that they work, has been quite an interesting journey.
This ties very deeply into your, I mean, themes of many of your presentations, most of your presentations, which are mostly live coded. So this ties back into the show and tell. I wanted to follow up on the previous question a bit because I'm also a teacher. I have taught hundreds of hours of video courses. I've spent thousands of hours in front of this microphone just creating learning material. And as a teacher, there is a temptation to fixate on ideas that have clicked in a certain way. So when you want to empathize with the audience, with somebody that is new to a technology, new to a concept, I mean, I'm talking about myself as a teacher. I'm clicking some ideas that I find particularly well threaded, and then there is a temptation to fixate on that thread and to refine that particular thread, if that makes sense. But with you, when you're teaching the same concept in many other presentations, you take it in many different ways, not necessarily refining that same idea and presented it in an ever clearer way, like 1% clearer and an ever incremental increase of clarity, but rather you present it in different ways from different points of view. And I wanted to ask about how you maintain that flexibility and how do you, say, grow your sensitivity towards other points of view. Does that make sense?
Sure. So part of that I would say is the topic is the same, but the time is different. The presenter is different. And I
Mm-hmm.
say the presenter is different because I am not the same person who was there 4 weeks ago because I've learned a few things along the way. My perspectives are shaped by the time and conversations along the way as well. I think that makes a big difference. This is where I think I'm sure you do that as well, to more extent than you probably want to admit, is that you bring in your new ideas and new learnings into it. Uh, I have to probably say, maybe a little cheekily say that this is one of the reasons why I don't create slides. To me, slides are too restrictive. They're too static for me. Whereas when I do live coding, when I have a list of topics to talk about, I can pretty much vary the flow. I would walk in and realize that this talk only is for 50 minutes, but I've given this for 90 minutes before. I can very easily tailor this to 50 minutes. So there is this nice buffering and a cushion that you can expand and contract, more being elastic, if you will. And to me, that flexibility comes from two things, I think. One is not having a static content like a slides to flip through. And the other is that one of the things I truly enjoy is when the audience poses a question and I can immediately start writing examples relevant to that question. That's been very rewarding. And that's one of the reasons I often tell people that no two presentation I make or no two course I teach is the same because the audience make the difference. So to me, that is, but the burden on that is that also requires me to do a lot more deeper research. It's somewhat a little bit easier to flip slides and walk away. But when you're doing live coding, when somebody asks you a question and you can modify the code, there's a bigger risk in it as well. Uh, but I think I've developed a bit of a sense of being shameless over time. And what I really truly appreciate is when things fall apart, programmers do two things I truly appreciate. The first thing is they are happy that things are failing because things are not failing only for them. It's failing for this idiot in front of them who is trying to make this presentation as well. And the second thing I've also found invariably beautiful is they would come to the rescue. And there have been times when somebody would say, go to the file you had open, go to line number 7, and you have a problem on that line. I'm like, darn it, that's pretty good memory of you watching it. But that also shows you that they are very attentive. As a speaker, the worst audience are the people who are disconnected. They're on their phone on and typing things and social media or browsing the web. But to know that the audience are engaged because they can find problems in your code and rescue you, I think there's no other proof that they are engaged and interacting with the talk. I think that to me is a big benefit. So to me, the audience shaped the presentation more than me shaping the presentation, I think.
This is amazing. And you're one of the reasons why most of my own presentations are live coded as well. Although most of my peers tell me that it's very scary, and they tell me that it's a difficult medium to work with, and it is because, as you said, it requires further research, and you need to be very well prepared, because live coding means that things will break in front of potentially hundreds of people in front of you. Any examples or stories that went wrong on stage and were particularly fun or instructive for you?
Oh my goodness. I will. This is interesting enough. This is captured on YouTube. So there is evidence to this to watch if anybody is interested. This was years ago. I was giving a keynote in Ukraine, in Kyiv, and I land about 2 hours before my keynote. What could possibly go wrong? So I land there. I take the cab, go to the venue, and the conference organizer, Mikhailov, amazing guy. We had not have not known him that much at that time. Since that time, I've become much more acquainted. But he comes over and says, are you ready? And there was like 600 people in the audience, waiting for this to talk. And I'm like, sure. And I literally flip open my laptop and I hear this, and I'm like, okay, that was not a good sound. And I'm pressing it, it's completely dead. So I'm like, oh my gosh, my laptop just crashed. And he was like, what do you mean your laptop crashed? I said, it's dead, it's cold, it's not going to come up. And he said, okay, fine. Give me a presentation. I'll put it on the another laptop and you can present it. And I said, I don't have a presentation. I don't have any slides. His face goes red. He says, wait, you have nothing to present and your computer is dead. Do you understand? There are 600 people waiting there for you to come in and start. And I'm like, you know what? Just calm down and think about it. He's like, calm down and think about it. What do I tell people? Like, hang on, just give me a minute. And I said, can you do me a favor? Can you find somebody with a Mac? He's like, you want me to find somebody with a Mac? Hang on. He looks through the audience, and this is where luck plays a role. Right in the middle of the room, there's one person with a Mac. He's like, hey, you, I want you. And the guy steps over. He's like, no, go back. I want your Mac. Come with your Mac. So the gentleman comes with his Mac. And I'm like, okay, so I need your request. I really have a request for you, please. My computer failed. Can I borrow your Mac? He's like, sure, here you go. I'm like, dude, your keyboard is different than what I'm used to. So you need to be my typist. I'm going to give the talk. You're going to do the typing. And when I need to type things, I'll get on your keyboard and type. But you need to have a terminal open for me because I can't use your IDs. I can't use your environment. I just need a terminal. Give me the REPL and I'm going to do things. As it turns out, this talk was on 5 languages on the JVM. So I'm going to do 5 languages demo as I'm speaking about it. So I'm giving the talk. This gentleman is standing there patiently. And I said, well, we're going to use Scala. And I turned around, looked at him and said, you got Scala, right? And he is doing brew install Scala while I'm giving the talk. And I walk over, I'm like, are you ready? And he gives me a terminal. I do a demo of Scala. And then I walk over, I'm giving a talk, and I said, next we're going to look at Clojure. And I look at him, he's doing brew install Clojure. So he's live installing language bundles. And we finished the talk, and everyone thought this was staged. But they
Wow.
wouldn't believe that this was completely a fiasco, and we found a way to recover it. And I think I don't think I have had another experience that comes any close to that. I've had a few failures along the way, but I think that one tops that for in terms of the complete failure and how we recovered during that 1 hour.
Spectacular recovery. And it wasn't a failure at all. I mean, it just goes to show that that a good presentation is actually in your head, not necessarily on the slides or on any sort of persistent medium that you are dependent on. So if you lose your memory stick with your slides or your Git repo for whatever reason, then you're dead if you rely on it. But if the presentation is in your head because you have a good breakdown of ideas, you have a good flow, and you know what sequence of examples you want to show, you don't really need you don't need slides or even your own computer. You can very easily swap it for somebody else's. So thank you for that story. I can I can imagine. I can only imagine what was in that room. Um, Venkat, I want to be respectful of your time because we're coming up on time. And before we wrap up this conversation, I wanted to ask you one question about your long career. And uh, you've been programming after decades, and I'm guessing it's not because of the math. And I think you said something. Please correct me if I'm wrong. Again, you cannot verify everything that you read about on the internet, but not because of the math or science, but because of the art of it. Uh, is that true? To what degree is that true? And how have you built the art part?
To me, that's actually more important than the math and science behind programming. Algorithms, data structures, sure, right? I've gone through the formal computer science education. Those things are exciting, and definitely people who appreciate it probably a lot more than I do. But for me, what has been exciting journey is uh, writing a code. Sometimes it feels like writing a poem. You have almost infinite number of ways to write code. And to me, when I write a piece of code, I often ask the question, can I make this more concise? Can I make it more expressive? Not make it terse, but make it concise and expressive. I have developed this sense of dislike for clutter. And when I look at a piece of code, uh, going back to the word you used earlier, it's the intuition, but maybe a bit more than intuition. Maybe it's an instinct. And when you look at a piece of code, it's an aversion towards it. Or you look at a piece of code and you say, "Wow, this is." I often say a good code invites the reader. So when you read something, it draws you in. It keeps you engaged. A poorly written code pushes you away. And this is not just about code alone, about books. One of the things that I'm a very impatient reader. I would start reading a book or an article, and I would just put it away because it doesn't excite me anymore. But then occasionally I come across a book. I cannot put it down. I'm reading page after page after page. I'm taking it on my trip, and I don't want to put it away. I'm taking it to the dinner, and I'm reading through it. And then I ask myself, why am I attached to this book that I'm not for other books? And I realize there are elements to this writing that really has drawn me in. It has really attracted me and invited me and said, you are welcome here. So that's basically the art form, in my opinion, is where it is, yes, the code is going to do stuff. It is going to pass your test cases, but is it understandable? Is it maintainable? It is expressive. Can you show this to people and say, here's what the code is doing, and will they understand it very quickly? That's the part that really truly excites me about code. And again, that's a part I'm also a little bit sad, because with AI, we probably are not going to see a whole lot of that if it turns out to be what it is. And but at the same time, I think we still have quite a bit of that in other aspects of life. Like I said, it's not just code alone. When I work with things, I often ask the question, can this be more intuitive? Can this be easier to use? Can this be easier to understand? So I think that nature of elegance and nature of expressiveness is something we're going to carry with us in very different forms, code just being one of them. And that kind of gives me happiness when I see things are expressive and elegant and not disruptive or confusing or intimidating, if you will.
I love how this ties into the theme of there's got to be a better way that we were discussing earlier, because as I was hearing you talk about how you perceive code, I saw that thread in I would like to make this code more elegant and more easy to read. It has to invite the reader and so on and so forth. So what I'm hearing from your answer is variations of there's got to be a better way. And normally so far in the podcast episodes that I've had until now, the last question that I asked my guest was, do you have any thoughts or quips or things that you would put on a giant billboard where that a million developers would read? Would there's got to be a better way be a good fit for the billboard? Would there be something else?
I think that can be a good fit. There's got to be a better way. But I also would say, probably off late, one of the things I've been emphasizing more is um, help and seek help. I think both of them are very highly relevant in today's world. To help others is genuinely humane quality, I think, but also to ask for help. I think some of us are too harsh on ourselves. We sometimes are more helpful than being willing to ask for help as well. But what I've realized is when I ask for help, the amount of generosity of people willing to help me is very humbling, in my opinion. I've had help from so many people who have gone out of their way to help me to become a better writer, a better thinker, a better programmer, a better person overall. I think I think it was Steve Jobs who said the best thing he did was to call somebody and ask for their advice. I wish more of us would do that. So I think if we can ask people for help, I think we will elevate ourselves, and then in turn we can help others to elevate themselves as well. So I would say help and be, help and seek help would be another thing I would say is worth looking at.
Amazing thoughts to wrap up. Venkat, it's been a pleasure. I'm so happy that I had this conversation. 2 hours flew by very quickly for me. I really, really appreciate your generosity with your time and with your advice. Until next time, thank you for listening. Venkat, it's been a pleasure. Thank you.
Thank you so much for having me. Appreciate it, and greetings to all your listeners as well. Thank you.